Yeah, this is Indian Foundry Organization which has started, and the main activity is interaction with the government. Please run it through. Of course, these are all the different teams. We have West Zone, we have South Zone, North. And see, 1 minute, government linkage. In the last 9 months, we have already established with the Ministry of Commerce and Industry, Ministry of Environment, Forest, Ministry of Finance, Heavy Industry, MSME, Government of Jharkhand, Government of Karnataka, Government of Odisha. In fact, the state governments have told us to bring people for investment in the foundry line. There is a lot of benefit in each of states. Odisha, in fact, they are told they will give land also free. We have interacted with the minister there, state government ministry, and he told he is prepared to give the land if some of you can come for investment in Odisha. Next one. This, of course, the beginning of the Indian Foundry Organization, which was started on 15th October in Bangalore. We had a lot of very senior bureaucrats there from ministry. Next one. Yeah, the same thing which we, next one. This is seminar which we had in Calcutta. Again, we had very senior bureaucrats in the meeting. Next one. Same thing. Next. This is Foundry Startup and Stand Up India, which we did in Jaipur. Next. The same thing in Jaipur. Next one. This is in Mumbai, where we did the innovation meet, where we honored and felicitated Mr. Vinod Kapoor with the Lifetime Achievement Award. Next one. This is the same Foundry Innovation Meet where we had full day discussion and things like that. Next one. This is the one in Bangalore. We had the Southern SME Meet sponsored by MSME and NSIC. NSIC CMD is there. DHI Joint Secretary, Senior Development Officer is there. And Government of Karnataka, we have the Development Commissioner of Industries who is there. Next one. We have meetings with several government ministries, and we have one-to-one interaction with several of the, you can just run, see this is with the Department of Heavy Industry. In fact, one of the vision documents they have given to the IFO to draft the vision document for Central Training Center, which will be established in Ranchi. Next. CEFC, that is the vision document which is being prepared and discussed with the Department of Heavy Industry. Next one. Environment and Forest and Climate Change, we were asked to represent there. MSME has invited IFO specially, no other association except FICCI, MSME and SIAM and the other one. The only 4 groups they called. State governments, we have very good interaction with Jharkhand. Next. Next. Investors Forum, we were involved totally. He's the Chief Minister of Jharkhand. And of course, sand problem, we also went to Andhra state where to solve the sand problem, sand supply problem. And Government of Karnataka, Chief Minister of Karnataka is there. With this Government Investors Forum, we were there. And Odisha, he is the Industries Minister, Industries and Mines Minister, Mr. Malik, Prafulla Malik. In fact, we had a very detailed discussion with Prafulla Malik. If any of you are interested in investments, there is, then Foundry Development Council, we went for the Foundry Development Council with the Department of Heavy Industries. We had the meeting there. And of course, the IFO had several MOUs, Memorandum of Understandings. One with the HEC Limited, which is the largest steel foundry. This for establishment of the sustainable manufacturing practices that has been assigned to us. And the other one, previous one is the Bangladesh Foundry Owners Association. In fact, we have a very good understanding with them. We are taking a delegation to Bangladesh where they want us to help them in several aspects like energy conservation, cost reduction and rejection reduction. We have MOU with colleges also, engineering colleges. Then ASM, we have a very close interaction. ASM represents the technical cell and we represent the policy making cell of metallurgy. Zone activities also have started in every zone. And this is at Ranchi. We visited RSB and RSB Foundry we visited. Next one. Next, of course, it is official meetings. We had the startup and stand-up meeting. One is that was in Chandigarh. This is in VIT Jaipur Engineering College. And South Zone we had the ASM meeting, and Foundry Skill Development Center has been assigned to us. IFO is taking the lead, and with Institute of Science and IIT Bombay we will be doing that. And of course we had meeting with the China Association, Smart Cities. Ms. Bina, we did participate in the Smart Cities, bottom left, Maharashtra. And this is what we have come in the media. This is just I wanted to show, he has left, Mr. Akar Foundries has left, but it is possible. We should have close interaction with the Government of India. And Mr. Paneer Selvam was there with us for several meetings. MSME is with us for several meetings. And we have been doing a lot of work, and it takes a lot of time. It is hardly, we are 10-month-old, and we have been able to establish very good contact with the government ministries. Thank you very much for listening.
Thank you, sir, for elaborating on your activities. We now move on to our next session on new products, innovation and productivity. To discuss about the newer developments in materials, innovation, techniques and productivity, may I call on stage our next speakers, Mr. Mahesh Kulkarni, Head of Business Development, Doran Troop. May I also like to call upon stage Ms. Sujata Tilak, Managing Director, Ascent Intellimation, and Dr. D.P. Mondal, Senior Principal Scientist, Advanced Materials and Processes Research Institute from Bhopal. I would request Mr. Mahesh Kulkarni to please begin the session with his presentation on neutral lining refractories for induction furnaces.
It was a very good session, last session. People were really are now fresh probably and awaking. So now it is not difficult for me to keep them awake. I will not take much time. This is basically I am talking about the refractory technologies. Now since morning people are talking about the new technologies and cost saving and everything. This is one part, refractory in a foundry is a vital part, and there are so many areas like induction furnace, ladle and other places where you can save money through choosing the right type of refractory. One which now I am going to show you is the neutral lining. This is basically for the induction furnaces to replace our traditional linings. I'll just give a brief introduction about our company. DFP, Doran Troop, is a German company. We have a manufacturing facility in Germany. It's 110-year-old company. 115 years old company. Since 1901, we are into this industry. The philosophy of our company is to, even after 115 years, we say that we learn, develop, improve every day. So it's like learning every day. Like we are, even after 150 years, we have to still say that no, there are so many things which are still needs improvement and development. We produce refractories for melting furnaces, holding furnaces, pouring, transport and treatment ladles. Basically the monolithic refractory materials for the steel and iron foundries. Of course for the non-ferrous foundries also, the complete set of non-ferrous foundries for the aluminum, for the copper. The castables for induction furnace, for the ladle, for the channel furnaces, auto pour and press pour. Then we have a prefabricated shapes for the spouts. Then the even now ready to install crucibles. We have up to 4 ton capacity. We can give the crucibles which are ready to install in the furnace. No need to do the lining on site. Then of course the tools for the lining vibrators and all. These are our mines in Germany. We have a mines in Sweden and Germany. So the we have a control on the raw material. This is our manufacturing facility. we have a dedicated line for the different products. The capacity of this is we can produce 35,000 to 40,000 tons of mass per year. This is a laboratory. Then the manufacturing for the prefabricated shapes, crucibles. Like as I told you, we can supply the complete crucible. This is the storage area. Yeah, now the main point. See, like we have two basically refractory which are used in the induction furnace, silica and magnesia. Silica means acidic, magnesia means basic. And the refractory basically chosen based on the type of the material which you are going to melt in the industry, into the melting furnace. For cast iron and SG iron melting, people are using silica. For the steel castings, it is being used the basic refractories. The third refractory, which is neutral, which was developed into the Europe a long back, and it has been used in the Europe since I think 15-20 years, but it was not adopted or not being popular in India. Since last 4-5 years, the neutral lining is now becoming popular in India. The reason being, this is having the neutral. It can be used either for the acidic slag as well as for the basic slags. So it can be used for the any kind of metal. But of course, we normally recommend it to use for the steel melting only. For the cast iron melting, we are still promoting the silica lining with boron oxide. Normally people are using with the boric acid, which we have to now change to the boron oxide. The main ingredients for the neutral lining is Al2O3, that is the aluminum oxide with MgO. It makes spinel bond, and that is why the alumina refractory is having the very high service temperature. Say 1800 degrees centigrade temperature it can withstand. The sinter layer formation, normally when we say for the refractory, there are the three zones: sinter zone, semi-sinter zone and powder zone. In neutral lining you will find a very thin and very strong sinter zone, and still powder zone will be there into the lining. So sinter, it has a protection. So when you have a powder zone, when any metal penetrates through the refractory, it will reach to the powder zone and then it will be stopped. So it increases the protection of your furnace. Lining is neutral in nature, so it has a very less slag attack. And the erosion, basically erosion of the lining is due to the either slag or the temperature. It has a 1800 degrees centigrade working temperature or service temperature and neutral into the nature, so the erosion because of the slag as well as the temperature is very less. It comes into the premix condition and do not require any heat up or mixing up with sintering. So major advantage of the neutral life of the furnace, insulation increases because of there is no moisture into the furnace, into the lining, and moisture release is not there during the sintering heat. Then liquid sintering is possible, so you can reduce the time of the sintering of your furnace. One can do, like say, one lining. Normally the acidic lining runs for a few number of heats, 18 to 20 or maximum 22 heats, whereas this lining runs for say 200 hours and number of heats around 70 to 80. I am just giving an example, 70 to 80 number of heats. So you can run your furnace continuously. The availability of the furnace increases for the production, and you can save on your sintering time, you can save on your labor. Recovery, okay, then another major advantage of this neutral lining is the recovery of ferroalloys. In silica lining with the steel castings or some of these special alloys, the recovery of alloys is less in silica lining, which we have practically observed, whereas in the neutral lining you can get the recovery, much better recovery for the manganese and all. This, in some of the even steel castings, it is very difficult to make into the silica lining, whereas in neutral you can make that kind of any special or any difficult castings which having a high alloys like moly and nickel and all. These castings you can make into the neutral lining without any problem. Then the inclusions into the molten metal, the refractory, normally which erosion of the refractory goes into the liquid metal itself, and neutral lining is having the very less erosion. So the inclusions into the metal because of the refractory are less. What are the savings? Say, as I told you, we can run the furnace continuously for say 1 week, and we can save on a former, because with the silica lining, if you want to do for a one silica lining 20 hits in a week, you have to go for either 1 or 2 patching or 2 lining, whereas here with neutral lining you will be able to run for a 70-80 hits. So you can run continuously for 1 week. You will be saving on your former, you will be saving on a sintering power, you will be saving on a man hours, you will be saving on a metal handling, even downtime of the furnace. This will in totality will give you the savings on the cost which you are spending for the neutral lining. Say suppose silica lining cost is around say 10 rupees or 12 rupees per kg, whereas the neutral lining cost is around 110 or 120 rupees per kg. With this huge difference, we did a lot of cost benefit analysis at many places, and we found that ultimately the owner or the user is getting benefit because of all these parameters like the savings and the quality plus the recovery from the ferroalloys. So it is like what we told into the another in the previous lecture or previous discussion, that it's a mindset of the people who has to be changed, and they should be given the cost benefits. They should understand that if you spend more initially, and a longer run it will be an advantageous. And I can say the successful example of this is in the morning, our customer Kirloskar Group, Kolhapur Steel, they got the award for the greener foundry. One of the initiatives they took is the change from silica lining to the neutral lining, and I can say that they are using since last 2.5 years successfully, and they are getting the benefit out of that. In short, we have to understand that in the initial stage the cost of the refractory is high. Even in the ladle refractory, nowadays people are using either the silica sand or the low cost castables. We did one project into the one foundry in Kolhapur, it's in Gadge Patil, where we changed all the silica sand ladles to the castables. There was a saving of around 900 tons of silica sand for a year. This is huge saving against the material which castables which they are spending. In totality they are saving on a labor, they are saving on a heating equipment, they are saving on a logistics, and of course the environment. So these are all benefits which are possible through refractory. You have to change your mindset, and you have to understand that the refractories is a vital part, and it is going to change the economics of a foundry industries. Yeah, this is the one just as on a sample, that the number of lining with the first lining maybe the cost of refractory is very high, but with the number of patchings, like you can go for a 7 or 8, 9 patchings, the cost of refractory will reduce. this is what I want to say. In these things, in a short, I would say that to achieve this greener future, we have to concentrate on a refractory, overall refractory of a plant. Thank you.
Thank you, Mr. Kulkarni. May I now call on stage Ms. Sujata Tilak, Managing Director, Ascent Intellimation, and she will talk about the Internet of Things, how they are changing the foundry sector. Over to you, ma'am.
Good afternoon, everybody. So I stand here as a representative of an industry which is not a foundry industry. So somebody in the previous discussion, it was suggested that foundry men should collaborate with other industries or people from other disciplines. And so I stand here as a representative of automation and IT industry, and I'll talk about industrial Internet of Things and how it can benefit foundry industry to achieve your goals for greener foundry, as well as increase the productivity and so on. Okay. Now, in general, if you see any industry, the industrial revolution, it has gone from a manual stage to an automated stage to today's industries are connected. So there is an evolution from manual to automated to connected, and different industries are at different levels of this. There is still some manual operation happening, and it will keep on happening, I think, even in future as well. Some industries are more automated and connected than other industries, and whatever I gathered from the previous discussion and my studies of foundry, foundry industry is not that much evolved in terms of being automated as well as connected. But then these technologies have helped other industries, so I'm sure they will help foundry industries as well if foundry industry decides to embrace them. So in short, I will talk about what is all this buzz which is being heard everywhere around. So what is IoT? So what is Internet of Things or IoT? So IoT is basically a network of uniquely addressable things which are capable of communicating with one another through internet as a infrastructure. So things are non-human equipment, so any equipment which is not directly operated by humans, and these things are collaborating with each other through internet as a medium in order to achieve some goal. So any system which works on this principle is a Internet of Things system. And there are two types of Internet of Things which have emerged. One is the consumer Internet of Things, and the second is the industrial Internet of Things. So this refers to the area in which the systems are used. So IIoT or industrial Internet of Things is used in industries. Another term all of you must have heard a lot of times is smart manufacturing. So what is smart manufacturing? So smart manufacturing are the systems which are fully integrated, collaborative, that respond in real time to meet changing demands and conditions in the factory, in the supply network, and in customer needs. So any system which is fully integrated, collaborative, and has the capability to respond to any changes in the demand in real time, it's a smart manufacturing system. And this is a concept, and there are different applications of this concept. And you can go from 100% integrated smart manufacturing factory to applying it to certain areas in your organization. And it doesn't have to be the entire smart factory. It can be smart operation, or it can be smart equipment, or it can be smart process. So you can apply it at any level which makes sense to you or which gives business benefits to you. And lastly, what is Industry 4.0? So this is nothing but a smart manufacturing initiative of German government. So smart manufacturing and Industry 4.0 both are same things. So Industry 4.0 is a specific initiative of German government. So these are both ways of ways of organizing manufacturing or ways of conducting manufacturing with the help of technology. And IIoT is a technology infrastructure or platform or specification which helps in fulfilling or which helps in providing solutions for smart manufacturing. So IIoT is a technology and smart manufacturing is a way of manufacturing things. Okay, now what are the challenges? Why would anyone want to go for smart manufacturing? And I'm sure since morning all of you have heard and debated about a lot of challenges facing the foundry industry, so probably I won't go into these details, I will just pass through this slide. And in the end, everybody wants to maximize certain things, productivity, quality, compliance to regulatory requirements, competitiveness and profit, and wants to reduce downtime, energy consumption, time to market, finished goods inventory and cost. So let it be any industry, this is what people strive for. Okay, now let's talk a little bit about what are the focus areas of Green Foundry, and I will talk about how IIoT or smart manufacturing can help in achieving these goals. So these are some of the areas which will help you or which will let you achieve greener operations. So efficient energy usage, efficient raw material usage, and minimization of emissions. Apart from this, there are some other areas, but I am concentrating on these because these can be directly delivered by smart manufacturing practices or IIoT solutions. So if you are able to achieve reduction in your rejections as well as reduction in the waste and improve process efficiency, then as a result of this you can achieve all these three goals. And how to do this? So both these things are possible through process optimization, right? And the process optimization at design time, so when you design the process, you design it such that it helps you achieve your goals. But along with the design time, you have to continuously at operation time also keep monitoring and analyzing what's actually happening on the ground. So in addition to the design time process optimization, it is necessary that you keep doing it every day. And for that you have to monitor your process in real time and you have to analyze what's happening in your process, and so that you know what to optimize and how to optimize. So at the production and operations time also there is continuous monitoring required. Then the other big area which affects a foundry, and I heard that the power costs are to the tune of 12 to 15%. So that is energy. So energy optimization is another area, and here again, to optimize anything, first you have to know what's happening, and for that you have to monitor. So monitoring the energy consumption and then analyzing it will help you to decide how to optimize the energy, and this is again going to help you achieve your goals for the Green Foundry. So this is the basic premise on which I am going to build my presentation. So which are the components which contribute to the Green Foundry? So by components I mean it could be processes or it could be departments in your foundry which are more responsible than others maybe. So your production processes, your production assets, that means the equipment that you are using, and raw materials. These are the three areas I think which are quite crucial for Green Foundry initiatives. And the departments which come in picture are engineering department, production department and the maintenance department. And IIoT systems can help in the areas which I have shown there. So to improve your production processes, to improve state of your assets, and they can help the production and maintenance department in achieving this. So the raw materials and the engineering parts I have omitted because IIoT systems primarily work in your operations or your manufacturing process and not so much at the design time or at the engineering time. And I have left out raw materials as well because I mean the IIoT systems can definitely tell you the composition of the raw material and how to tune it, etc., etc. But that the major portion is in the production process and the assets. So I will show you a typical deployment of an IIoT system and how it can be deployed in a foundry. So these are I have shown here different sections in a foundry, typical foundry. So you have core making, melt, you have the furnaces, you have the actual casting, heat treatment and machining. So these are generally the areas in foundry. For an IIoT system to work, the basic requirement is the ability to collect real-time data from different equipments in each of these sections. So there has to be some kind of automation, some kind of sensor, some kind of data acquisition mechanism through which real-time data is collected from each of these areas of the foundry. And this DAM, it's a data acquisition module. So some hardware which will collect this data from all these sections. It's easier said than done. There are a lot of challenges in doing this, and this is the biggest challenge in deploying any IIoT system for any industry, not just foundry. In any industry, the biggest challenge lies here: how to connect to the equipment and how to collect the data in real time. Once you have achieved it, this is called as the edge layer. In IIoT terminology, this is called as an edge layer. So you are at the edge of your network, and at the edge you have the equipment and you have the data collection equipment. Then comes the platform layer. So at the platform layer, IIoT server will sit, and this could be right from in your own foundry to cloud, anywhere, and all the data which is collected from different sections is going to this IIoT server. And this could be from one location, this could be from multiple locations. So if there are multiple foundries and all of the same organization, all of them could be on the same server. So the data is going to the server. This server is basically providing all the functionality that is required for your IIoT system. Now what that functionality is will depend on what are your business objectives and what you want to achieve out of that system. So I won't really go into the exact functionality, but in general there will be some functionality which will help you running your foundry better. So improve your production processes, improve the state of your, or help you improve. The system itself won't improve anything. The system will just help you improve these things. And then the last layer is the enterprise layer. So this is your ERP, your CRM, or your CMMS system, or whatever. And there is a information exchange between the IIoT server and your enterprise systems, because finally everything is working for the same organization, and the one of the basic premise of designing any IT system is you should not create islands of systems. You should always try to create connected enterprise or digital enterprise, and for that every system should have the capability of connecting to other systems, and it should not run in its own proprietary island. Okay, so that's why the enterprise system and the IIoT system should connect to each other. And in Ascent Television we have a IIoT server and IIoT platform called Plant Connect S Factory, which is suitable for any smart factory application. Yeah. Now IIoT contributes in several areas, as I already mentioned. So process monitoring, energy monitoring, emission monitoring, condition based maintenance, and integration and aggregation. So these are some of the KPIs which are generally used in foundries. So the capacity utilization, yield, rejection percentage, OEE, and specific energy consumption, sand and water consumption, and there may be many more. So I won't go into these details. Okay, these are some of the parameters which you can monitor. But then this list is very just representative list. I'm sure all of you have much better idea of what you want to monitor to achieve your business goals than what I can tell you. And then there is some system setup where you have to set up some set points, tolerances, some master data about the raw material and so on and so forth. So how or in what area or what do you do and what is the result or what is the outcome of that? So you acquire parameters from your process, from your energy and from your emissions, and using this data the system will give you real-time analysis and feedback for process improvement, for energy conservation, and for identifying the process bottlenecks. So for example, I just have one or two examples just to relate it to the things on ground. So it will be possible for you to know the exact downtime of various equipment. Now today if you want to know the downtime, maybe you have to depend on the operators and you have to depend on them to know at what time it went down, why it went down, and at what time it came up. So in this case you will come to know of the downtime directly from that equipment itself. So that equipment is communicating with a system and it stops communicating means it is down, and that's how you will know what is the exact downtime. And any downtime more than a tolerance limit, you can make the users enter reason for why it was down. So you are basically making people accountable for whatever is happening on the shop floor, and that itself will be a big motivator for them to ensure that the equipment are not down for any reason which is not acceptable to the management. Similarly, you can get alerts in real time for parameters which are beyond tolerance. So you set tolerances for the parameters, and if they are going beyond that tolerance, you can get an alert, and there can be an escalation mechanism for that alert. So initially, it won't happen if it happens once. So let's say some parameter has gone beyond tolerance and that condition stays for say 5 minutes, or it is recurrently occurring. So the parameter is going beyond tolerance maybe 5 times in 1 hour. Then you will get an alert. And the escalation mechanism can be set in where initially the operator gets an alert. If he doesn't take any action, then the shift supervisor gets an alert. If nothing happens, then the manager will get an alert, and so on. And you can process the energy parameters and the energy data, and you can correlate the energy data with the process data, and that will help you optimize the process in order to reduce the energy consumption. So I had some discussions on this particular topic with Mr. Shyam Arjunwadkar here, and if time permits, maybe he can give his opinion on this particular topic in few minutes to the audience as well. So these are some of the goals which you could set for yourself, and set the system in order to achieve these goals. And once the goals are achieved, you can go to the next set of goals and so on. And think of the impact on environment as well as bottom line, and of course profitability of your organization. Then the next area is maintenance. In that, preventive maintenance as well as condition-based maintenance, for both the system can help you. So the system can give you running hours of your equipment, and I think it is much better to say that change filter after the equipment has run for 600 hours rather than saying change it every month, because you are then doing just in time maintenance, not too early and not too late, and this system will very easily help you achieve that. And a little bit more complex is the predictive maintenance, where you can define conditions in your system and the system will give you alerts when those conditions are true. and then you can take appropriate steps of scheduling some maintenance in order to make sure that your equipment doesn't fail. So it's basically before the equipment is actually failed, you can set conditions to give you advance warning. More advanced ways are comparing current patterns with your historical data or with your golden batch and giving you suggestions in order to change the parameters in order to achieve the best results. Or machine learning, where if a failure occurs, the system will know what were the different parameters or the entire condition at that time of that failure. And if in future a similar condition starts developing, the system can warn you that, this might mean this particular failure, and this way the system can learn on its own as days go and becomes more and more mature and more intelligent. And lastly, as I already talked about, integration and aggregation with the enterprise system. So integration in terms of production schedule, CMMS, ERP, and aggregation with other systems. So to go for such a system is a business decision and not a technology decision. So don't go to this because IIoT is the buzzword, it's a new technology. No, you have to have some solid business reasons to go for such a system. So I have put some steps as to how you can go about such a exercise. So first is identify potential areas. That means identify business benefits or business objectives, why you would want to do something like this. And they could be, very small things like today you are doing some manual entries in some logbooks for your parameters, and you want to, and of course that is, fraught with errors and omissions and so on, and you want to bring in complete accuracy and reliability in that. To you have a poor OE, to whatever. So there could be a number of reasons. So identify your reasons. Then define overall strategy, how you want to go about it. From top down to, I'm just finishing, 2 minutes. So you set your goals, whether you want to go top down, bottom up, you decide. Most important is to have a buy-in from everybody in the plant, to train people, to make them aware. They should not look at these systems as, somebody is monitoring me all the time or somebody is taking away my job. So those kind of feelings could hamper the entire exercise. So getting buy-in from everybody is very important. And then training, customer engagement, explain it to your customer as to what advantages they will get and so on and so forth. Then you have to, so this is the preparation. Then you have to define phases and set specific goals. So you have to have measurable goals as to what do you want to achieve by this system, and then only you should start, and you have to get your vendor to say, yes, I will help you achieve this goal. And after that, evaluate and identify product and then implement. Okay, so I have a few things on how to choose a product, and I will just, actually this is very important, but due to lack of time, I will just skip this. And just a slide on us. So Ascent Intellimation, we are a Pune-based IT company focused on industrial automation. And we have been propagating convergence of industrial automation and information technology for last 5-6 years, and only now that has been become a widespread concept from IoT and Industry 4.0 and stuff like that. So we have an IoT platform called Plant Connect, and there are several solutions based on this platform. I already talked about S-Factory, which is a smart factory solution. Then we have a remote asset monitoring solution for OEM. We have an environment data monitoring solution called Enviro Connect. So this is monitoring stack emissions, ambient air quality, ETP output, and so on. And we have a solution called Insights, which is historian and reporting solution for process plants. So that's all. And do we have time to take questions or no?
We can take it later on after the session is over.
Okay.
Yeah.
Okay, so
And
thank you
thanks a
very
lot for your presentation on industrial Internet of Things. We have covered your quotes in our lead story of Foundry Review in today's monthly edition. Thank you for that. And our next author, Dr. D.P. Mondal, is a senior principal scientist and currently heading the division of lightweight metallic materials at CSIR, Advanced Materials and Process Research Institute from Bhopal. His research interest is deformation behavior, advanced casting technology, aluminum metal, matrix composites, metal foams. He will present on the topic of stir casting for the development of lightweight aluminum.
Good afternoon, everybody. It is my privilege to thank the organizer for inviting me to put my thoughts to the galaxy of foundrymen here in this event. Actually, this is some kind of different topics than what you are being here for this whole day. This is a material development. And it is one kind of new materials. Mainly in the foundry, we are looking for to get a dense material. Here, our aim to get a material with more porosity. It should be a porous material. And this is called, these are the aluminum foams, because aluminum is a light material. If we put the pores, it will be much more light. And these materials have some special characteristics, and it could be used in lot of applications. It is a multifunctional materials. And in the forum of green foundry, it may not, I am not talking about the green foundry, but this material can be considered as a green material, which could be used for such application where the greenhouse gas emission could be reduced significantly. Next. And this is a material, while it deforms at very low plateau stress and give a very high densification strain, because at least around 70 to 80% strain it gives, and its plateau stress means yield stress is very low. So at a very low stress level, it absorbs huge amount of energy. And that's why this material can be used for crashworthiness application, mainly for crashworthiness application, for blast resistance application in defense, and also for the core of the sandwich panels. And later I will see the slides where you can see that there are a lot of material can be saved if you use the core, foam core sandwich panel for structural application. And if you see its application, because it is a porous material, it has huge surface area, and it can be used for heat exchanger as well as for crashworthiness. Even our bone are also porous, because most of the woods all are porous, because we get this concept from the natures. While the natures, all the materials are porous, so we can also use the porous materials for a lot of applications. And as far as engineering concerned, it has a wide range of application from heat exchanger to crashworthiness, impact energy absorption, vibration control, and noise attenuation. And in the car, in the automobile sector, it has a lot of application. If you see from the bumper to the crash box to the pillar of the tube, pillar of the chassis tube, there in everywhere we can use this material for improvement of the crashworthiness of the vehicles as well as for comfort drive of the cars. And it has a huge application. If we can make, if the foams are made in the form of sandwich panels, it will be very light. And it has very high fire resistance property. It has a very high fire resistance property. It can be used for the attenuation of the blast. Means in defense, it has lot of application. US defense is also trying to use this material in their cars, and also it has the foam core sandwich panels, multi-layer armors in their tank and all these things, that the US defense is trying to use this material. And these are the some I have taken from the nets. These are the testing they have done for blast resistance. This is for the multi-layer armor for where the aluminum foam is kept at the core, and at the top they have kept the ceramic armor materials, dense alumina ceramics or zirconia oxides ceramics can be used, and at the bottom they use the fiber reinforced polymer. So in this way, multi-layer armor material have the better capability to resist the ballistic of higher caliber. So, and they are using this in their tank, even in the tank. And this can be welded also. These foam materials can be welded also. And it can be given any kind of shape. So with this lot of application, we in CSI Rampri tried to develop this material through star casting technique. And report says that if the material, this foam material, replace the conventional material in a ship, it can reduce the weight of the ship by 1,000 to 10,000 tons. So it can that the ship would be very much lighter. That hydrogen gas gets entrapped within the metal, and it will give you the bubble, and you will get the metallic foam. And this, after adding, here you will adding the calcium, that is added for control the viscosity of the melt. Instead of calcium, you can use other ceramic materials also, even the fly ash or cenospheres, that can also be used as the thickening agent to control the viscosity of the melt. And at that case, this material will be very, very cheap as compared to other foam, because fly ash and cenosphere is highly costing anything. Then this thickened metal is stirred, and simultaneously you have to add the foaming agent for uniform distribution of the foaming agent. And that particle size of the foaming agent is also important. It should not be of nano size or so that it gets coagulated and it does not mix within the metal. But that size of the foaming agent should also be controlled. And some technique is there. You should ensure that the foaming agent has gone inside the metal to some kind of modification should be used for adding this foaming agent within the metal. It may be, suppose you have the foaming agent, you can add with the aluminum powder, make it compact, and then you add slowly within the melt and stir it so that it gets uniformly distributed within the melt. And after adding the foaming agent, it will start foaming. And at that time, this crucible should be taken out from the furnace, and it should be cooled at very fast rate, either spraying of water or spraying of air. And after getting the foam billet, it should be sliced, it should be joined into the plates, or it could be machined into the form of tubes and anything, and then it can be used for your desired application. So, and these are the powder metallurgy technique, where the metal powder and the foaming agent is mixed, compacted, then extruded, rolled, and then it is formed at high temperature. So here you can get a section which is filled with foam, because you can get the precursor through this technique and then use this precursor within your desired component, and you heat it at the suitable temperature. This material will get foam and fill that component what you want to fill with the metal foam. This is the system, this is a small kind of system we are using for the star casting technique. We should have a stirrer at the top, and we should have a furnace, and we should have a crucible within the furnace. And then within the crucible we should melt, and after melting we should add the thickening agent. After adding the thickening agent we should add the foaming agent. But all these additions should be carried out through mechanical stirring. And for better distribution, prior to adding, you can go for two-step process. First you make the composites, and that composite may go for ultrasonic stirring if the particles are very, very fine. And then after getting that finely distributed composite with fine distributed particles, you can remelt that composite and then add the foaming agent. And during this time, you should control the temperature. You should have control on the stirring speed, and you should have the facility to take the crucible after foaming and cool it at very high rate. And these crucibles should be split type crucible, because after foaming you should take out the foam. So every time you have to use the split type of crucible. And this crucible is put within the furnace, and then we add all these things and do the foaming, and this is the crucible with foam. And after that, that crucible is splitted into two parts. We take out the foam billet. And now we have established a semi-automatic system where we can, this is the furnace where we can put around 6 to 8 crucibles which are preheated at a particular temperature. And then we have another furnace where we can melt these materials, and another furnace where we can make the foam. In that furnace, we should take the crucible from here to that furnace. There also we control the temperature, and melt is taken from this furnace to the foaming furnace. And this is the stirrer which can be put on this, and it is hydraulically operated. It can up and down. And we have also one crane. That crane is used for shifting all the crucible and also the crucible after foaming. So it is semi-automatically developed, and it can be developed with much more automation for increasing the foam production. And these are the different kind of edge. And through this foaming, this crucible, through this we can make a 30 kg of foam at a time. So in single crucible we can make 30 kg of foam. So if we are through the whole day, now we can make 250 kg of foam in a day in our laboratory. And this is the casting size, and from there we can slice the foam into different thickness. And if we see the microstructure, it has a different, depending on the foaming temperature, we have different size of the pores. And if the pore size increases, we will get different density. We can achieve, we have achieved a density up to 0.25 gram per cc. That much density we can achieve, because this material is needed for crashworthiness. It should have very low density. But for structural application, if we go like sandwich panel and other things, it needs higher strength. So there we can also make a foam of having a density of 0.8 to 0.9 gram per cc. And this has been, we have made another attempt to make the foam much cheaper, because most of the cost come from the foaming agent. That is the hydride. And these hydride are very, very costly in nowadays. So around 50% of the cost come from the hydride. So, and the other 50% of the cost that we cannot reduce because it is needed. So we should reduce the cost of the hydride. That cost can be reduced significantly by using this very cheap material which is a byproduct of thermal power plant, that is cenosphere. These cenosphere are porous in nature but micron in size. And if we can have the material like this instead of composite, we should have a material having a cenosphere within it. So it will have already some porosity. And then if we melt it and foam it, so our requirement of foaming agent is reduced significantly. Suppose in case of while we are adding SiC as the thickening agent, we add around 1 to 1.2% of hydride. But in case of this, if we use cenosphere, around 0.5 to 0.68% of hydride is sufficient. Thus, it will reduce the cost of the foam by 30 to 40%. And it can be made into any shape. If we get the crucible where we are foaming, it should have the particular shape. The foam can be made into any shape. And using our foam, we have made some prototype component like crash box for the automobile, inverter bracket for the also buses, and the sandwich panels where we have the foam at the core and on both the sides we have the fiber reinforced composite. So to develop our confidence, we have made this type of prototype component. And this foam has been tested and it can give a plateau stress from 1 MPa to as 25 MPa and through the control of the relative density. And the norms are coming for greater crash worthiness of your vehicles. So these materials will have lot of demand in near future for using in the crash box or bumpers or pillar of the pillars and all these things in automobiles. And defense has also invited us to join their program for development of blast resistance material, mainly the foam material for their application. And we are joining with the defense also. And these are the different way we have optimized the process parameter and as well as the cenosphere size. Because this material has lot of future, because through the use of cenosphere, which is a thermal power plant OS, the foam cost could be reduced significantly by 30 to 40%, where the cells of the cenosphere will give additional strength within the foam. So we will get the strength as well as more energy absorption, and as well as we can reduce the cost of the foam through the use of these micro balloons, which is called cenosphere within the metal. And we have done some fundamental study how the orientation of the cells affect the strength of the foam materials. And that was, I was telling, if the foam is used as the core for the sandwich panels, for having the same density, same bending stiffness, you can reduce the weight instead of steel. If you use the foam core sandwich panel for the same bending stiffness, the weight will be reduced by 50%. And for in case of aluminum sheet, if you use the foam core sandwich panel, you can reduce the weight by 40%. So there are huge scope for using this aluminum foam in the sandwich panels. And if the sandwich panel is made in this way and the foam cost is reduced, it can be used in variety of application, even in domestic application like a partition panel, door panel, wall mounting panel, sound absorption panel. So even it has a wide range of demand. Its demand will be very high. So with this we have, there it is the report of Alulite who are making the foam, that if the foam is used as a score in the sandwich panels, its weight will be reduced significantly. And in this direction we are also working. And this is if you see the property of our foam, it is comparable to the internationally available foam which is made by Alulite and Alporus. And this is the conclusion. We have developed our confidence for making the aluminum foam in lab scale, and the technology is almost ready, and we can transfer the technology to industry, and it does not need a huge amount of money to set up an industry. Around 5 to 6 crore money is sufficient to make a foam of around 500 to 600 kg per day. And I think it's the overall turnover, if in the present time, when the government is making this norm for improved crashworthiness of the vehicles, also they are also trying to use this material in the rails. So it will have a huge demand, and that amount can be returned back within a year and a half or two. Thank you.
Thank you, Dr. Mondal, for your presentation on aluminum castings. We have one comment by Dr. Shivamarjun Wadkar on the productivity for Internet of Things.